Hello, let's get started with a forecasting question. So in question one, we have a time series of Alabama building contracts values for a 12-month period, and we want to construct a line chart, a time series plot, and then we want to see what type of pattern exists in the data, and then we want to do a 4-month moving average forecast as well as an exponential smoothing forecast with alpha equal to 30%, and then we want to compare these two based on MSE, and at the end we want to actually come up with just one number as our best forecast for the next month. So let's actually go to the data file and get started. So here's the data file. So here's the time series. So for the first part, for the line chart for visualization, so let me just go back to the question. So the question actually is for a time series plot, which is basically a simple line chart, and then comment on the pattern, type of pattern that exists. So for the line chart, I simply need to select the column, all my data points, and then insert a line chart, and then I just need to make it a little bit nicer and cleaner by removing the grid line and adding axis title, horizontal and vertical. So vertical title would be values in dollars, $1,000,000, and then horizontal axis title would be period number. I can actually go ahead and add a trend line here by right click on one of these data points and then add trend line. So as you can see here, the trend line looks like to be a flat line. I don't see a straight line either increasing or decreasing, so it's kind of a horizontal line, and it actually indicates that the pattern that exists. So let me just put it here, and then part A. So this is the line chart, and then the pattern that I actually observe here would be a horizontal pattern. Horizontal or stationary pattern. Either one is fine. So that's for part 1. And then now we want to do a 4-month moving average and exponential smoothing with alpha 30%. So let's get started. Let's actually do 4-month moving average first, and then let's actually calculate MSE right away. After we do each one, let's do MSE, and then we can compare at the end. So the idea here is that we want to forecast for the last month, for just 1 month in future. Let me just highlight it. So this is what I want to predict in future. So I'm going to start with moving average and K equal to 4, which basically means that I'm going to use 4 path month. So if I go to my formula sheet here, so moving average forecast is simply the simple average of past K. Why? So forecasting for period T plus 1 is actual observation in period T, actual observation in period T minus 1, all the way to T minus k plus 1 divided by k, or yeah, so that's it. So I just need to consider the average of past k, and k is equal to 4. So I don't have, for period 1, I don't have the past 4, so I won't be able to calculate for period 1. Same for period 2 and period 3 and period 4. I don't, for period 4, I don't have the past 4. I just have past 3, 1 and 2 and 3. So I won't be able to calculate for period 4, but for period 5, I can go ahead and calculate it, and it's going to be average of past 4 observations, which basically is observation 1, 2, 3, and 4. And then let me just show you the formula. And if I simply drag it down, it's going to give me the forecast, moving average forecast with k equal to 4. So at each period, let's say at the last period, the one that we want to forecast would be the simple average of past 4, which is period 9, 10, 11, and 12. So that's our moving average forecast. Let's go ahead and calculate MSE for this one right away before we do exponential smoothing. So error square. So MSE is, let me just show you here. MSE is the mean MSE is the average of error squared. So we need to calculate error squared for each period, and then the simple average of error squares would be MSE, mean squared error. So let me just go back here. So error squared. So error would be actual for each period. So actual number, actual observation of value of contract minus forecast. This is a forecast error, and then squared would be error squared for period 5. And then I won't be able to calculate error squared for period 4 because I don't have any forecast at here. So I just have the observation at period 4, but I don't have the forecast here. So I won't be able to calculate it here. I won't be able to calculate for period 3, 2, and 1 either. So, and then if I just drag it down, that would give me the error squared for period 5, for 5th until 12. And I won't be able to calculate for the period 13 here because I don't have the actual observation. If I drag it down one more step, it's going to give me a huge number because it's just comparing this against 0. So it's not good. We shouldn't calculate this one. So I'm just going to Control Z just to go back and undo what I just did. So that's for error squared, and then MSE, mean squared error for moving average, is simply the average of these guys. That's for moving average. Let's do, and then using moving average, this is my forecast for the next period, 297.5. So for now we just have these forecasts. For particular technique. We just need to do exponential smoothing and check to see if that one gives us a better forecast or not. Exponential smoothing, alpha 30%. So it's always good if you can fix alpha somewhere and just refer to it. Alpha 30%. Okay. So exponential smoothing. If we go back to our formula sheet, we'll see that exponential smoothing. This is the formula. So forecast for a period. So this is actually an iterative process. You see, we need to do it. So each period actually, the forecast at each period depends on the forecast at previous period. And then, so we have to start from period 1 all the way to period t+1, which is, here is, we have 12 periods, 12 plus 1 is 13. And then for period 1, the forecast is the actual observation in period 1. And then the forecast at period t+1 is a weighted average of the actual observation in the previous period, which is t, and the forecast in previous period, which is y hat t. So alpha moving factor would be the weight on the actual observation in previous period, and 1 minus alpha would be the weight on the previous forecast. So let me just go ahead and do it. So the forecast at period 1, that's our convention. It's always going to be equal to the actual observation at period 1. So let me just show you the formula. So first period equal to the actual number in period 1, and then second one would be alpha fixed. I can fix it using F4 on Windows and Command T on Mac. So F4 times, because I want to drag it down, so I want this to be fixed, to be the same for each one of those. Alpha times actual observation in previous period, which is this one, actual observation in period 1 plus 1 minus alpha parenthesis closed times previous forecast, F2 in this case. And then, okay. And then I simply, so if we check again the formula sheet, after period 2, the formula is going to be the same. So I can simply drag it down. If I just drag this down, it's going to give me the forecast. Then my forecast for the next period, period 13, is going to be 300.9, which is, I guess, slightly different yet. So we had 297 before, and now we have 300. So I just need to, so just to make it a little bit nicer, I can reduce the number of decimals here, decrease decimals, right? Maybe 1 decimal is more than enough. So now I need to do exactly the same thing. We want to calculate MSE, this time for exponential smoothing. So again, I need to calculate error square, and it would be equal parenthesis actual number minus exponential of moving squared. And you just need to simply drag it there. But again, we won't be able to calculate for this period, because if we do it here, this would be compared against 0 here. So since we don't have any actual observation here, we have to stop at 12. We shouldn't calculate for the period 13. So we have to stop here. So now, again, let me just make it a bit nicer by decreasing the number of decimals. So now, MSE for exponential of moving, if I just copy the formula and put it here, and then update this one, exponential of moving. What I did, I just selected these 4 cells, Control C, or copy from here, copy, and then select these 4 same corresponding actually cells for exponential of moving this time, and then paste here, paste formulas. So you'll see that it will give you, if you right click on this, if you double click on this, you'll see that it's the average of same like corresponding cells. So it's average of H4 to H13, which basically gives you the average of period 5, 6, 7, 8, 9, 10, 11, and 12. So this is the best actually. If you want to compare 2 methods, it's always best to compare the same corresponding cells. But like I said, even if you do, even in here, because you have error squared from period 1 all the way to 12, even if you change it from H6, instead of H6, if you put it F2 to F13, that's still okay. It's not wrong. But that one, the one that we had before, H6 to H13, this is definitely the best way of comparison, because you're comparing apple to apple. But like I said, even if you make it H2 to H13 like the book does, it's okay. There's nothing wrong here. So now, when we compare the error MSE of these 2 methods, we'll see that MSE of exponential of moving is considerably lower than MSE of moving average. So we take this one as our better approach, better techniques for forecasting, and then our forecast for the next period would be this number. So let me go back to the question and make sure that we've got everything. So compare a 4-month moving average forecast with an exponential moving forecast. So I have a 4-month moving average and an exponential moving with alpha 30%, which provides a better forecast. So I just need to put here lower MSE, better forecast. Lower MSE better. Okay. Which provides a better forecast based on MSE, the one with lowest MSE, which is exponential smoothing. What is your best forecast for the next one? So part C. Is equal to 300.9 for the next one. That's it for this question.